Hi everyone. In this video session, we are going to discuss the Wheatstone Bridge. Objective: at the end of this video, you will be able to measure the unknown resistance using a Wheatstone bridge. What is a Wheatstone Bridge? Wheatstone Bridge is an electrical circuit that was improved by Sir Charles Wheatstone in the year 1843. It is used to measure the unknown resistance from 1 ohm to a few mega ohms. An electrical bridge consists of two branches of a parallel circuit joined by a galvanometer and used for determining the value of an unknown resistance in one of the branches. Where are Wheatstone bridges used? The Wheatstone bridge is used for the precise measurement of load resistance. Wheatstone bridges are mostly used in industries as transducers to sense temperature, pressure, and displacement in the form of change in a resistance. How does the Wheatstone bridge work? Let's go with an example. Assume the cost of 5 apples is 50 rupees. If you are asked to find the cost of 10 apples, you will calculate 10 apples cost by comparing it with the known cost of 1 apple. Likewise, in Wheatstone bridge, an unknown resistor value is measured by comparing it with a known resistor value. What is the principle behind the Wheatstone bridge? Wheatstone bridges use the null deflection or balanced method of operation. A Wheatstone bridge is more accurate than the other methods of measuring resistance because the resistance is obtained using the null method or balanced method. Let's discuss balanced and unbalanced circuits. Two resistors, namely P and Q, are connected in series at point A. Similarly, another set of resistors, namely R and S, are connected in series at point B. Now two sets of resistors are connected in parallel at points C and D. Connect a lamp or bulb between points A and B. Assume that the current flowing through each component at P, Q, R and S is I1, I2, I3 and I4 respectively, and IL at the lamp. When the circuit is connected to a voltage source between the points C and D, current will flow in all the components and the lamp will also glow. This condition is called an unbalanced condition due to the different current flow and occurs when the ratio of resistor P upon Q is not equal to R upon S. Condition 2. Suppose if the currents I1 and I2 are equal and the currents I3 and I4 are equal, no voltage source exists between points A and B, hence no current flows to the bulb, which means the bulb is off. This condition is called balanced or null deflection and is used to calculate the unknown resistance in a Wheatstone bridge. It occurs when the ratio of P upon Q is equal to R upon S. In brief, if the ratio of P upon Q is not equal to R upon S, an unbalanced condition exists and the bulb will glow due to the current flow. If the ratio of P upon Q is equal to R upon S, a balanced condition occurs and the bulb will not glow, hence no current flow. Let's discuss the values. Case 1. Let's assume the resistor values of P, Q, R and S are 100 ohms, 50 ohms, 75 ohms and 25 ohms respectively. When we substitute resistance values into the ratios 100 upon 50 equal to 75 upon 25, you will get 2 equal to 3, which is not equal, hence the circuit is unbalanced. So a potential difference exists between A and B, which causes current flow and the bulb will glow. How to make the circuit balanced? Replace the resistor R with a variable resistor and set it to the same value of 75 ohms. Reduce the resistor value R from 75 ohms to 50 ohms to balance the circuit. Substitute the value in the ratio and you will get 100 upon 50 is equal to 50 upon 25 and the result is 2 equal to 2. Since the ratio is balanced, no voltage exists and no current flows in the bulb. Case 2. Let's assume the resistor values of P, Q, R and S are 1000 ohms, 10 ohms, 500 ohms and 100 ohms respectively. When we substitute resistance values into the ratios P upon Q is equal to R upon S, 1000 upon 10 is equal to 500 upon 100. Ratio is 10:5, which is not equal, hence the circuit is unbalanced. So a potential difference exists between A and B, which causes current flow and the bulb will glow. To make the circuit balanced, replace the resistor Q with a variable resistor or a decayed resistance box and increase the resistance values from 10 ohm to 200 ohm so that the circuit gets balanced. Substitute the value in the ratio and you will get 1000 by 200 is equal to 500 upon 100 and the result is 5 equal to 5. Method 2. Otherwise, put a variable resistor at S and reduce the value from 100 ohm to 5 ohm so that the circuit becomes balanced by the ratio 10:10. Since the ratio is balanced, no voltage exists and no current flows in the bulb. Let's discuss with bridge circuit. Connect the resistors P, Q, R and S in a diamond shape to form a bridge. Let the resistors P and Q be fixed values of 200 ohm and 50 ohm respectively, and the resistor R be a variable resistor or decayed resistance box, selecting the range at any value where S is the unknown resistance to be measured. Connect a galvanometer between the points A and B to sense the current flow. The galvanometer will tell you whether to increase or decrease the resistance to achieve a balanced bridge. Connect the battery to the circuit between the points C and D with a switch. Energize the circuit by closing the switch S. You could see a deflection in the galvanometer either on the right or left side. If the galvanometer deflects on the right side, reduce the resistance value at variable resistor R so that the galvanometer needle moves towards the zero position needle at the center position. Keep reducing the resistance value in the decayed resistance box until the galvanometer needle reaches the zero position exactly. If the galvanometer deflects to the left, raise the resistance value at R until the galvanometer reaches zero. Now note the resistance R from the decayed resistance box. Keep increasing the resistance values until the galvanometer reading reaches zero exactly. Take note of the resistance value of variable resistor R and enter it into the ratio. P upon Q is equal to R upon S. If the resistance value of R is 100, then the ratio is 200 upon 50 equal to 100 upon S. S is equal to 200 upon 50 into 100. S is equal to 400 ohms. Hence, the unknown resistance S is found to be 400 ohms. Let's discuss it with another bridge circuit. Assume a bridge circuit with 4 resistors P, Q, R and S. Let the resistors R and S have fixed values of 500 ohms and 1000 ohms respectively, and let P be variable 1 and Q be an unknown resistance. Set the resistance value of resistor P to 1000 ohms. Connect the galvanometer between the points A and B and the battery with switch S between C and D. Once the switch is closed, you can see the galvanometer needle deflect from 0 to some range, which may be right side or left side readings. Let us assume the galvanometer deflects on the right side. This indicates that the circuit is in an unbalanced condition. Now gradually reduce the resistance at the resistor P until the zero position exactly, which is a balanced condition. Note the resistance value of P. After balancing, let's assume the resistance value is 500 ohms. Substitute the values of P, R and S in the ratio. P upon Q is equal to R upon S. 500 upon Q is equal to 500 upon 1000. From this, Q is equal to 500 upon 1000 into 500 ohms. So we get Q to be 250 ohms. In the above two circuits, unknown resistance was found by comparing it with the known resistance value. Thus, the Wheatstone Bridge circuit requires 4 resistors with 2 known resistors and 1 variable resistor for balancing the bridge and a 4th resistor that has to be measured. For our convenience, we can connect the variable resistor to any arm of the bridge circuit. I believe that after watching this video, you will be able to construct a bridge circuit and find the unknown resistance value by the Wheatstone method. Thank you for watching. Have a good day.